not going to hit much of it in detail, but we're going to hit a lot. And then we'll slowly go back and go more into detail on some of the separate parts. So get out your calculators. That's the first thing, is I want to make sure we can do this in our calculators. Did everybody get one of each of the two sheets? If you came in late, didn't hear me or something. Everybody's got both sheets? Okay, so then get your calculator out. And if you go to the back, the data's on there. I wrote down all the points. And I'm going to show you how to put those in the calculator and make your calculator do a bunch of work. You ready? Calculator's ready? Alright, hit stat. And then edit. Remember, if you want, if you have numbers in there, go up to the top and hit clear and then enter. If you hit delete, it destroys it. It deletes the whole row. We don't want to do that. Maybe we can fix it, but it's just kind of a pain. And then we're going to type in the points. And the order does matter. So the first point is 60 and 5.5. They have to go next to each other. Now you can do all the x's first and all the y's second, but they have to go together. Because that's a data point, right? That's someone. I don't know who it was, but that's a person in this class. So they have to go next to each other. So I'm just going down the whole left-hand side, but just make sure you do the same order. The x values I wrote them out in order, but if you're typing them in, they don't have to be. It was just easiest for me to do that. So this should be 14 data points. So it should, at the bottom, it should be asking you for the 15th, basically. Just gotta look up when you're done, so I know you. Or I guess put your calculator down would be a good way. Unless you'll stand. It's weird. The next chapter test, the AP. It's the last day of the AP testing, so 14th or something. I don't know. Around there. I'm totally guessing.
I think that's the last day. I think that was the day of the 8th.
It's a 2-week stretch where they give them all, and I know it's the second Friday. It's the last. I think Cup's the first day, if I remember right. So there's a huge stretch. Yeah, so around 14th, 15th. What? Are we good? We got them in? Okay. What I want to do a couple things. But first, I want to have the calculator get the line of best fit. So let me show you what we're going for up here, and then I'll show you how your calculator does it. So when you, I hope you guys can see this. This is a really good site. It's got a lot of stuff on it, but it's kind of small. Can you guys see that decent? Even in the back, you alright? So what we want is the line of best fit. So it's called the regression line. So if I just click a button on here, it tells me, but obviously you're not going to have this for your test or anything. But your calculator does all this stuff too. It is called the least squared regression line. So if I put this up, I'm just going to click this button to show you kind of what it's calculating. So it's called the least squares regression line because what the calculator is doing or what it's calculating is it takes each point. So this is a point, and it draws a vertical line, whether it's above or below a vertical line, to this diagonal line, and then turns that into a square. And the least squared regression line is the line that would make the size of these squares combined least squares, right? As small as possible. So like if if I had something like this and I try to draw my line up there, I'm going to have all of these gigantic squares. That'd be like the most squared regression line. That'd be awful. So what we're trying to do and what's being calculated is try to draw a line so that these boxes that are being made, when I add them all up, they're as small as possible. And you never have to do that, but it is called the least squared regression line, and hopefully that helps understand like why it's called that. All right, let's get it. Okay. So the equation that we're looking for comes in two ways it gets presented to you on the AP test. We'll practice all this stuff. Again, this is like a huge overview. Kind of doing like almost all the chapter in one day. And then we'll go back and like piecemeal break it down. This is the equation that we want. You guys are used to seeing it more like this. I'll tell you what that hat is in a second. So they kind of flip it here, and your calculator could do this either way. But the number in front of this is your x variable, the explanatory. The number in front of the x is your slope. And the number just chilling by itself is the y-intercept. Your calculator can find that. They also will give you this table. This table looks way more confusing than it is, but here's the secret. Doesn't matter, doesn't matter, doesn't matter. This is your slope every single time. And this is your y-intercept every single time. So if I gave you this table and said find the equation, just take that, slide in the slope spot, take that, slide in the y-intercept spot. Again, just two ways they represent the same thing. So let's see if your calculator comes up with these same numbers. So let me go through how to do that. It doesn't, something's weird. Okay, go to stat again. Wow, that's large. That's like my grandparents' books. Calculate. And then we're going to scroll down to lin-reg. There's two versions of, so this means linear regression. That's what we're doing. We're taking a bunch of data and we're trying to run a line through it and say, okay, this is the best representation we can do. So it's linear regression line. You can write it in two forms. A is, you guys are used to seeing A as M. I don't know, they call it B here, but this is like y equals ax plus b, so which one's the slope there? A or B? A. This, they'll do the exact same calculation, but they'll write it that way. Which one's the slope there? B. So I think most of you are used to this. I'm used to this, so I'm going to choose this one every time. But you could do this one too if you wanted, or if you see it that way. It means the same thing, they just kind of flip the things around. So I'm going to choose number 4. That's what I'm used to. And then I get this x list, y list. So it should default to, we put the x values in L1, we put the y values in L2. I forgot this exists. Give me a second, I want to make sure I know what I'm doing here before I... With what words? It doesn't have L1 and L2? So you can type them in.
No, like it just came up. It didn't go up.
It's like the
Oh, right. There's like the two versions of it. Okay.
So if we don't
Just hit
do
enter.
that, we don't-
You don't need to. You don't need to worry about it. So yours just it just skipped through it, buddy. If you just hit enter, you should get that. Are we getting that? Same numbers? That's the same numbers the calculator showed too, right? Or my computer program thing showed too. All right. So let's go to our sheet here. Write a couple things down. We're gonna plow through this sheet. What is the x value in this situation? We got this big graph that we made on Friday. I gave you a copy of it. What's the x value? No, sorry. What's the x variable mean? I wrote that wrong. What is the x variable? That's what I should have said. X variable is your height. That's my bad. And what's the y variable that we're working with? Shoe size. So we are trying to say that if I tell you my height, you can predict my shoe size. So now I say write the formal version of this equation. So the non-formal version, like the kind of lazy algebra way, would be to say y equals 0.563x minus 29. It's not lazy because I'm rounding, like the rounding is whatever. This is not a complete answer. This would actually be, I think, marked fully wrong in AP Stats. Because they want it, just like everything else we do, we want it in context. So there's two things you got to think about with context. I need to label those variables. And, so let's start with that. So I'm going to go, okay, height equals 0.563 times shoe size minus 29. Alternatively, you could write it this kind of lazier way, and then below it go, hey, by the way, y is height, bless you, and x is shoe size. So if you do that whole thing, it's complete, and if you do this whole thing, it's complete. But you're putting context in the variable, so it's not just y and x. And the second thing, is it true that if I tell you my shoe size is 12, for example, you can run it through this calculation and find my exact... Why are these backwards?
Yeah.
Did you guys figure it out and fix it for me? X value is height. Y value is shoe size. I'm so sorry. So y equals 0.563x minus 29. So it'd be shoe size equals 0.563 times height minus 29. Or you can do this version and then you can say, oh, hey, y is shoe size, x is height. I apologize. You guys know what I was trying to say? What I'm saying now? Like I hope I didn't screw it, but I haven't. We alright? Cole's leaving because I'm in this. Okay, the second thing. So is it true that if I tell you my height and I plug it into this equation, you will get my exact shoe size? Will it be exactly my shoe size?
No.
No. Thank you. It's a predicted shoe size. It's an estimated shoe size. It's what we would expect to happen, and the way you indicate that is you put this little hat on top of the y variable. And that means it's just what we expect to happen. It doesn't necessarily mean it's going to happen. It's what is expected based on this line that we drew. It doesn't mean, like, if I tell you my height, you can plug it in and get the exact shoe size. That's like chapter 17 or something. Slow down. We'll get there, but... So when I ask you to write the equation, you got to keep two things in mind. One is the context, so you put those variables, and the other is this hat. If you don't put this hat on, like this would probably be worth 2 points for writing this equation. You'd lose one. Because then you're saying this equation works every single time. That's not the case. It's just like what we expect or on average or predicted values. All right, question on those two. All right, let's jump to finally interpret the slope. Number 3. 0.563, right? I found it. Step 1. Nice. Interpret is a little tougher. But keep in mind the slope. So I'm going to put this over 1. Because I want slope to be a fraction. Sometimes it is a fraction. It'll be like 3 over 2, and then it already is. But if it's not, I'm going to put it over 1 because it's easier for me to think about it in that way. And then slope is the change in y over the change in x, or the change in x over the change in y. Change in y over change in x. You guys know this triangle means change. Like delta y over delta x. All these like delta faucets, delta airlines. They want you to think they're changing, and they're very advanced. They're always changing with the times, so they make their logo a delta. And then I'm going to kind of go back to the very first thing I thought of. Well, the y variable, this is the change in shoe size. This is the change in height. And you don't have to break it down this way, but I think it really helps you kind of organize your thoughts, because you're going to be asked to describe it in this way. What I'm going to say is for each additional inch of height, start there. For each additional inch of height, is it true that the shoe size will increase by 0.563? Like, for a fact, the shoe size, so you just grew an inch, your shoe size automatically got 0.563 bigger. No, it's what we expect, it's what's on average. So we're going to say we expect shoe size to increase by 0.563. And I don't care if you show this, but again, I think it really helps you organize, like, okay, this is the y value and it's changing 0.563, this is the x value, it's changing 1. Just kind of line it up your thoughts and organize. But that would be fine to interpret the slope. Questions there?
So if we just put like the word definition or the word answer, would we get full credit, or would we have to put both?
If it says find and interpret, you're going to write slope is this, and then you're going to write this sentence. You don't have to show like this.
Okay.
Where is this expect in our original equation? What indicates expect in our original equation up here? That hat, right? So we're basically writing out the same idea there. Let's go like this. Okay, find and interpret the y-intercept. Well, what is the y-intercept? Negative 29. That is really a point. 0, negative 29, isn't it? I don't have to write that. But again, I'm just trying to help you organize your thoughts. And then this is your x value. And this is your y value. And what's x in this case? Height, right? So this is your height. And this is your shoe size. But again, it's an expectation. It's what we predict. And some of these make no sense. This one makes no sense. This could never happen. But we could still be asked to interpret it. So what we would say here is someone with a height of 0 this is terrible grammar, just ignore that. Okay. We'd expect to have a shoe size of what? Of negative 29. And then sometimes the AP test, they'll follow it up and say, does this make any sense in a real life context? And you think, no. Yeah. 0 height is like, even Riley's taller than that. Questions on anything I've done yet? All right?
So really, if you just mess up slope, you can mess up both.
If you mess up slope, you're, yeah.
They kind of do that kind of thing.
Yeah. If you mess up that equation, you're basically there. Yeah. No big deal.
Lost.
It's wrong after, but you're also right.
Let's see. I'm gonna change. I'm gonna shift my plan a little bit here. I was gonna go through everything at once, but I'm not sure that's the best. Okay, I want you to do. So we haven't learned all this stuff by any means. Kind of going more piecemeal than I thought I would. I want you to do. I want this. I want you to show me the scatter plot with the regression line and the point, not with the points on it. No, you don't. I don't have to do that. I don't care about that. I want you to sketch the scatter plot. No, I don't. I don't even care about that. I want this, this, and this. Sorry. And let's say that L1 is chapter 1 test, and L2 is chapter 2 test. I know you can't see it, but I said it, and I'll move in a second. Calm down. So just so you have context. This is made up data. There weren't like 10s and 20s on the chapter test. Everybody have the equation yet? Did you get what I got? Alternatively here, you could go y hat equals 0.946 times x plus 27, and then label y is chapter 2, x is chapter 1. So you're just providing context in a different way if you do it that way. Both of those are acceptable. And then I'll give you a minute to do the slope and the y-intercept. I could feel people's attention going away. That's why I was like, okay, we should switch gears instead of doing everything all at once. Which is fine.
Steal food for a minute.
Oh, play some food. Yeah, that's yours. Yeah. slope or the y-intercept? You're right. Those are the grades, yeah. So, like, if someone got a 10 on the first test, let's try to predict their second test. Yeah, so chapter 1 test grade, I guess. Chapter 2 test grades. So everybody, how many got the equation? Like your calculator functioned correctly and you got the correct equation. Anybody have an issue with that? How many got the equation right, like in context? We good there? Should I wait a second to do the slope and y-intercept? A couple people are still writing. I'll wait a minute. And you don't worry about anything else. We haven't talked about R squared, form, direction, strength, anything. Okay, so give the slope. The slope is 0.946. Interpret it. I'm going to think about it as 0.946 over 1, where 0.94, that's y over x. So the 0.946 is the y, which represents chapter 2. The x represents chapter 1. Again, you don't have to show this part, but it just helps me kind of organize, okay, this is what goes where. And then I'd say for each additional point on chapter 1 test, what's the next phrase? We expect, or you could say we predict, a 0.946 increase on chapter 2. Questions on that? When he had something like that. Okay. Y-intercept, what is the y-intercept? 2.7, whatever, okay. So that is really the point like 0, comma 2.7, right? Which is always x, comma y, which is chapter 1, comma chapter 2. So if someone got a 0 on chapter 1, what's next? We expect a 2.7 on chapter 2. Questions? All right, go to the next one. I think we're just going to do slope and y-intercept today. That's good. So this one is going to be toppings on a pizza. And cost. It's really freaking expensive toppings. And do the same deal. I want the regression line equation, the slope, and the y-intercepts. Who's sighing? That didn't help me. That's okay. I would be getting a 1 topping pizza from this place. Actually, I'd be getting a 0 topping. They would pay me. We wouldn't really need to do a line of best fit for a pizza place. Like, the prices just kind of are the prices, so this is not like the most ideal made up scenario, but just roll with it. Oh, for your test, I can't get them back yet because there's 1 or 2, I can't remember, people that haven't taken it yet. There will be some sort of a retake or correction or something for a third of your points back. The average is pretty good, so I don't need to do like a ton of recovery, but I want it to be available if you want it. And I'll have that to you as soon as the last person takes it, which hopefully it's there tomorrow. So it's a 1.14 over 1. And that is the cost over the toppings. Do you have it backwards? So you were saying like for each dollar we'd get 8 more toppings? That'd be awesome. No, why? Rise over run. Hey, if you write rise over run, my Alexa said. If you write rise over run that way, the Y, I think you spell rise wrong, but it helps you remember this Y. L1's always X. Yeah. No, it's changing Y for changing it. Slope is Y for X. That's where you're missing. Yeah. I think you meant to when I wrote that. I went to put in your test grade this morning and I couldn't find your name. It took me like a full minute. So I was looking for mine.
Oh.
And now it doesn't say it anymore.
Oh, yeah.
Yeah. It's like, did he drop my class? What is happening?
I'm just showing up here, so I actually don't.
Right, you're just auditing.
Yes. I'm online.
I just like stand so much. You need to figure out slope right now.
I got it. I already got
Oh, okay. All right. So, I mean, I can talk through it, but it's up there. Predicted cost, make sure you have predicted here with the little hat on top. Cost is the Y value, 8.14 times topping is the X value, minus 12.57. So for each additional topping, like each additional X value basically, we'd expect the cost for the Y value to increase by $8.14. Expensive toppings. Y-intercept for a 0 topping pizza, we'd expect it to cost negative $12.57. Yeah, I would order like 1 million 0 topping pizzas. So it doesn't really make sense like in the context, but how many had something appropriate here? You guys good? Okay, you may be annoyed, but I don't care. Do another one. I mean, I don't know if we're to the point where like this is stupid and boring, Mr. Davis. I don't care. People screw this up like constantly. Like I feel like you guys think it's easy and no big deal, and then like I don't know what the deal is, but I'm gonna do some overkill. Deal with it. L1 is Monday's temperature. L2 is Tuesday's. So we're trying to see if we can predict Tuesday's temperature based on Monday's. Mr. Davis is stupid, I get it. Shut up. What? Tuesday's Michigan? This is all Michigan. It's -5 on Monday and then 10 on Tuesday. Yeah. Could someone confirm that they got the same numbers as me before I start writing something? Okay. What do you mean it's not working? Like what's not working? Did you double check that you put the numbers in right? If you missed one, like if you have different amounts of numbers in the two lists, it won't work. This is a negative slope, right? So your temperature is going to decrease. The last two were both increase. This will decrease with negative. Did you get it figured out? Like from the last one? Like way down the bottom or something? Oh man. I mean, no one's touched the calculator except for you. So. That's the last one, I promise. We're just going to summarize in a second. You alright, Sophia? Struggle on a Monday?
Bonus? Every time you advertise your company?
Yeah. Like if I go there, you should get a commission. How many would I have here? We alright? Yeah. Alright, so one more thing I want you to do, and I'm going to write down my own notes, but you might want to write your own. I don't know. If you go to the very back, I kind of put like, we're going to do like separate notes on each of these things that we're going to go through. So at the bottom here is notes on slope. So I left space there for you to like make your own note on how you want to remember to do slope. You could also just copy what I read if you want. I'm going to think about it as changing y over changing x. And I'm going to say for each additional x variable, we expect whatever the y variable is to increase or decrease by whatever the slope is. So like if you memorize that kind of template or outline, that would work. If you have your own way of thinking about it, write your own way in there. Looks like a lot of you are just copying my way of thinking. Totally fine. Just so you can look back at this page later and study, like, okay, this is what I did for slope, this is what I did for r squared, this is what I did for r, these different things. Good there? You still right? You good? And then on the top of the next page is y-intercept. So if, let's say x value is 0 for x variable, we expect y variable to be, and then whatever the y-intercept is. So that's just what you did the last, you just did it 3 times. Just like summarizing it for you so you can look back at that later. Question then, so today was just, can you find the equation in your calculator? And then can you interpret the slope and the y-intercept? Good? Questions? Alright, thanks for stopping by. Bring this, for the next week or so. We're going to just keep going through that.
Yeah. Yeah, you just have to pass. If you have to see why. Because I didn't know my class